Hey guys, welcome back to another Leetcode Problem solving tutorial, and in this tutorial I'm going to be showing you guys how we can solve Leetcode Problem 22, generate parentheses. So this question is basically going to give us a number only from 1 to 8, and it wants us to generate all the different possible combinations of parentheses there could be. So for example, if n was 3, you'd have 3 open and 3 closed parentheses to use, and it wants you to generate all the possible pairs of valid parentheses. So immediately we should be able to recognize that we can use a recursive sort of thing, especially when it comes with generating combinations. Recursion is usually the best way to do these kind of things. So let's think about this. Let's go over to here. I'll just refresh the page. Okay, so we're starting off. Let's just assume n equals, let's just start with an easy number. So let's start with 2. Now, as we start, we know the first one always has to be an open bracket because we can't have a closed bracket. If we have a closed bracket, then that's immediately invalid because no valid string is going to start with a closed bracket since there's not going to be anything to close. So we start with the open bracket. Then what we can do is we've already used up 1, so now we have 1 open bracket left. So we can either add another open bracket or we can close the existing one. Either one is a valid next move. From here, what we can do is we've used up both of our open brackets since n was 2, so now the only thing we can do is close one of them. And from here, we can either open another one, or we can, actually we can't close anything because there's nothing to close. The singular bracket has been closed. So these are the two next options. And then of course from here we can only close another one since we have no open brackets left. And same here, we've used both our open brackets, so that is the only solutions. And you can see how we've managed to get these. So hopefully you can see that at each stage we have a possible of 2 choices, and sometimes it's only one depending on the circumstances. And let me make these a bit more clear. What I'm going to do is I'm going to create a new function just called generate, and this is going to be our recursive function. So I'm going to take in, well, first of all I'm going to take in a list object, and this is just what we're going to use to store our combinations. So this isn't going to matter too much. Same way I'm going to take in n just so I can sort of have it in my function. And then what I'm going to do is I'm going to keep track of how many we've had open. So we'll say open, this is the number of brackets, open and closed, number of closed brackets. And that's the parameters we need. So to start this off, what I'm going to do is just create a list called combinations, and then we'll run generate on this list of combinations. We'll pass in n, and then initially there's 0 and 0. Right, let me define this to be a number. So yeah, initially there's going to be 0 open and 0 closed. Now what we want to do is we want to check if we have any open brackets remaining. And to do that, what we can do is we just check if open is less than n. If this is true, then we obviously have some open brackets remaining to use. We have some open brackets remaining to use because n is a maximum number of open brackets we can use, and if the number of open brackets we currently have used is less than that, that means we still have some. So in this case, what we can do is we can immediately generate a new combination, passing the same parameters, except this time, oh, sorry, I forgot the most important part, which is the current string. And this is going to initialize as an empty string, and this just stores our current state of our brackets, kind of like what these are storing. That's very important. So yeah, anyways, now what I could do is if we have open brackets remaining, we can just immediately create a new string, current, and add a new open bracket, and also add one to our open bracket counter, and the number of closed brackets hasn't changed. So this is what we can do if we have open brackets remaining. Now check if there are any brackets that need to be closed. And to do this, we can just check if the number of closed brackets is less than the number of open brackets. So in this case, number of closed brackets is 0, number of open brackets is 1. Sorry, number of open brackets is 2, so we can add a closed bracket and it will still be valid. However, in this case, the number of open is 1 and the number of closed is also 1, so we can't add another close or else we'd be closing nothing. So when we can add a closed bracket, let's also add that, basically spawning new instances, and instead of adding an open bracket, we're going to add a closed bracket, and then increment 1 to close, like so. Pretty simple stuff. So this is all fine, but now we need some kind of break statement. So our break statement is just going to be if open and closed are both equal to n, that's going to mean that we can't really do anything, so that means our string is finished. So that's one possibility. Just check if opened is equal to n and closed is equal to n. In this case, we cannot do anything, so our string is complete. That's the takeaway. And another way we could check this is just check if the length of this is equal to 2n. That would also imply that the string is closed. But yeah, so in this case what we're going to do is simply add it to combinations. That's why I passed it by reference, so I can just push it in like so. I'll push in our current. This should actually be a string array, like so. And yeah, when we've completed our string, we're just going to add it to the finished combinations, and then we can just return combinations like so. So you should see, if I run this, what question was this? Question number 22. Okay, let me just run it. So let's just say console.log generate parentheses 3 to use the example here, and you can see it generates them all fine. So I'm just going to copy and paste this in, and we will submit it and see what our time looks like. This was a pretty simple solution, and yeah, so we don't get too good. Our memory is also not too good. Honestly, I think that's because we're doing a lot of passing into between functions. And one thing I could do is create combinations as an external variable, like so. Now here we won't have to delete, we don't have to run it there. And maybe if we just don't pass around these lists as much, that would hopefully reduce the time. Okay, let's try this again, see if we get any improvements. Oh, okay, what's gone on here? Right, I'm not actually sure what's happened here. Maybe this is ending as soon as it's completed one run. Oh no, I know what's happened here. Since we created the combinations as, okay, we can fix this fairly easily by just resetting it before we run it. It's because this is initializing the global scope, and then likely they're just running this function multiple times, so it's not really, we need to reset it before we create any new combinations. Let's see if this helps at all. Okay, there we go. Yeah, so we do a bit better beat now. We're in above average rather than below average, so it's decent. But yeah, this was a fairly simple algorithm. Hopefully you guys can see how it works, and thanks for watching. I'll see you guys in a future tutorial. Bye.